Following on from the previous video, we got to this stage here. We got to this stage. We got to this stage here. So we had two vectors, 1, 2. Perform the cross product. That will then give us this normal vector. So now that we've got the normal vector, we need to set up. Well, we need to demand that any general point needs to be at 90 degrees to the normal vector. Because if you choose a general point to, let's say you've got a general point here, let's say p x, let's say x y z is over here. Well, this point here is not at 90 degrees to the normal vector, so this point is no good. If you have a point that lies on the plane, then it will be at 90 degrees to the normal. So we demand that a general point like this must be at 90 degrees to the normal vector. And the way we do that is to demand that the dot product of the normal vector and the vector from A to P must be equal to 0. Remember, in order for two vectors to be orthogonal to each other, the dot product must equal 0. So we need to demand that our general point here must be at 90 degrees to the normal vector. So we need to demand this. But the thing is, we need this from A to P. So this P here is, hang on, we need this vector here from A to P. But the thing is, remember, A is floating in the middle of nowhere. A currently is at 1, 0, -1. So I don't know where the xy coordinates are. Hang on, let's just say this is your x, y, and z coordinate. Don't forget, A is floating in the middle of nowhere. B is floating in the middle of nowhere. C is floating in the middle of nowhere. But we need this vector here. We need from A to our general point. So, well, if you just simply use x, y, and z, then that will give you from the origin to here. But we don't want from the origin to here. We need it from A to P. So we need from A to P. Well, from A to P, well, if you want this vector here from A to P, well, currently you are at 1. How would you get to here? Well, you from A. Don't forget the origin is somewhere down here. This is the origin because this is your x, y, and z. A is floating in the middle of nowhere. So if you want to get from A to P, then you simply get this, take away this. So you simply get x, take away 1. So you are currently at 1. How would you you are currently at 1 here. How would you get to this x place? Well, you would need to move this much to get from here to here in the x direction. Now let's look at it in the y direction. You are currently at 0. How would you get to the y? You're currently at 0. How would you get to the y? Well, you need to move this much across in the y direction. So now you are currently at -1. How would you move to z? Well, you need to move this much in the z direction. Simply get this, take away this. So from A to the general point will be given by this. Okay, so yeah, from A to P will be given by this. Now remember we need to demand that the dot product of the normal vector and from A to P must be orthogonal to each other. So we need to demand this. So now I'm just going to write the vector, the normal vector. This is our normal vector. But I'm just going to rewrite it in this form because it's easier to see. So if you look at this, you've got minus 15. You've got -15, 9, 1. You've got -15, 9, 1. So it's just me writing it in this form. And then this is our vector from A to P. Our vector from A to P is given by this. I'm just going to write in this form so it looks nicer. Okay, so now the dot product, remember, we demand the dot product to be 0. So the dot product would be this times this, that will then give you this, plus this times this, plus this times this, that will be this. Remember, we demand that this to be equal to 0. And then now it's just a matter of tidying things up. So this times this, that will then give you this. This times this will then give you this. Blah blah blah. And then just tidy this up. Single number, move everything across. So this is your equation for the plane. Okay.